Hi, I thought I'd do a short tutorial series on how to use a circuit simulator, or in this case LTSPICE. It's a simulator based on the Spice circuit engine. I've done a few videos in the past on using LTSPICE for doing various little niche simulation things I wanted to do at the time, but I haven't done a complete beginner's thing from the very start. There are lots of these sorts of videos, beginners videos and tutorials on LTSPICE out there, but I thought I'd throw my own hat into the ring. Now, the good thing about LTSPICE, which is one of my favorite circuit SPICE simulators at the moment, A, because it's free, which is always fantastic. B, as I said, tons of support out there for it. And C, it does actually work fairly well as a circuit simulator. Now, unfortunately, LTSPICE is not the easiest to use circuit simulator out there. So if you want a real dummies version that just allows you to do some real basic stuff, LTSPICE probably isn't for you. It's designed as a very powerful, in-depth, professional SPICE tool. So really, there are quite a few traps in these things because, actually, which comes from its name. Its name is SPICE, is an acronym for Simulation Program with Integrated Circuit Emphasis, and hence the name. There is an emphasis for integrated circuits, silicon level simulation. Now, SPICE started in the mid-70s to do just that because people couldn't breadboard their integrated circuits, right? You can't breadboard your silicon stuff. So they developed this to try and simulate it, and as such, actually, a lot of people don't know, but SPICE simulators out of the box are not entirely optimized for the top level stuff, which most people use it for, the board level stuff, your op amps, your switching regulators, and all that sort of thing. It's out of the box. It doesn't, what's called, a lot of the time, it won't converge or generate a be able to solve your particular circuit. You really got to tweak this and tweak that. Now, the good thing about LTSPICE is that as you get it out of the package, it has actually been tweaked and optimized for pretty good convergence for board level circuits, and in the case of LTSPICE, more specifically designed for power switching regulator simulation and stuff like that. But as a general purpose simulator, it does work really well. So the majority of circuit simulators out there use some variation of the open source SPICE engine, and LTSPICE is no exception. Now, SPICE was and still is traditionally a command line driven program that you write your SPICE code, your SPICE script, you feed it in, and it gives you a solution. Now, what LTSPICE and all the other most of the other circuit simulators is a big, nice graphical user interface wrapper around the SPICE engine. So you can actually see, you can draw your schematic and see the components, you can do all that sort of stuff, you can draw graphs and you can interact with the circuit and probe things and all that sort of stuff. So that's what LTSPICE allows you to do. So we're going to start with a new schematic here. And pretty much these are all your tools up the top that you use to draw your circuit. Now, what every single SPICE circuit must have is a ground point. It must have a known reference ground point like that. If it doesn't have that, it just screws up and it's not going to work for you. So a lot of beginners fall into the trap of not putting a ground point. Now, here's the other components: resistors, capacitors, inductors, diodes, and then your more big selection of components. So we can start out by just putting a couple of resistors in here like this. You can press Control R to rotate like that, and we can have our little merry circuit in there, and we can draw ourselves, something like your traditional resistor puzzle or something like that. Now, then you can go in there with the wiring tool, and you can just wire things up like that, and it is quite easy to use. You'll notice that little box around the point on the end of the resistor there, that indicates that that node is not connected. So if you see any of those boxes on your schematics at all, then you will know that that point is unconnected. So, and it automatically puts the junctions in there, and it is fairly easy to just draw up your circuit like this. No problems whatsoever. Now, Spice engine like this really, you can't just go run and solve and put the values in there, and it's not going to tell you the total resistance of this circuit like a resistor cube or something like that. It's not really designed to do that. Spice engines are designed to operate with various sources, voltage sources, and we'll look at the different types of sources in various videos, and we'll also look at the different types of simulation. So this video will only show one type of simulation today, the very simplest one, but basically we need to go up there and put a voltage source in. So we can go up to components here, and here are all of our components. We've got all different categories. There's all different types. We've got transmission lines, we've got transistors, all sorts of stuff. But what we want is a voltage over here. So that can give us our voltage source. But the voltage source is actually very powerful when we go in there. We can set the value to 1 volt by right-clicking on that. But if we go into the Advanced tab, you can see that's not just a voltage source, but we can have not just a DC voltage source, but it can be a sinusoidal source, it can be a pulse source, it can be a piecewise linear source, and all sorts of stuff. But we're just going to use it as a DC source in this one. And we can just wire that up, and it's pretty easy to draw your circuit like that. And once again, you've got to connect that ground to some point in there. But bingo, we have a simple circuit. Now, at the very least, each component is going to have a reference designator, in this case R1 here and V1 up here, just like you're used to in your traditional schematic editor, and it's going to have a value associated with it. In terms of the voltage source over here, we've got 1 volt DC, and this resistor here, we can just right-click on that value, and here is one of the first traps is you can type in, of course, the resistance is going to be in ohms, and the capacitance will be in farads, the inductance will be in henries. So you have to put in the right units. You can, of course, put in 1,000 ohms like that, but you can put in 1K like that, and it's going to recognize upper or lowercase. It's going to recognize that. But a lot of people, a lot of beginners, the first thing they fall into is they go 1 meg like that. That is not 1 meg. Okay, you see how it's converted. I typed in uppercase M and it's converted it to lowercase m there. That's actually 1 milli. All of the Spice engines recognize M as milli, not as meg. So if you want meg, you've got to actually type in 1 meg like that. I know it's crazy, but that's what you have to do. And if you don't do that, you're going to be out by orders of magnitude, and that's a trap almost every beginner falls into. So there you go. We're going to try K there like that, and of course, if you want 1 mic, say you've got a resistance isn't going to be that low generally, but a capacitor, you can put in U like that, and it will. You notice how it's turned the U into the mu symbol, which is 1 micro. So let's change that back to 1K, and now we have a silly little resistor puzzle here. And how do we solve it? Now the next thing, well, what we do now is, what we want to do is go into Simulate and the Edit Simulation command here. Now we haven't had it added what's called any Spice directives yet. We haven't told the Spice engine what to actually do, and here's where we can do this. Now we've got 6 different types of simulation, and I'll have to do a separate video on each one of these because they're very important, the different types of simulations you can do. Now there's actually more than these 6 here, or you can actually do various combinations of things, and we'll go into these in future videos. But the main ones that most people are going to use are Transient Analysis, and that is your traditional time domain, i.e. your oscilloscope type view. You'll be able to view waveform, probe your circuit, view waveforms as the circuit starts up over time, just like an oscilloscope. And then we've got AC analysis, which allows you to do AC frequency sweeps of your circuit. Like if you've got a filter, for example, you can sweep it over a frequency range and you can get a Bode plot. Then we've got various DC sweeps where we can sweep and change the DC operating point, which is a more advanced version of the very simple DC operating point we're going to look at today. And then you can do noise analysis, DC transfer analysis. They're your more advanced type stuff that we'll get into much later on. But the one we're going to look at is DC operating point, and this is the absolute simplest bare bones SPICE simulation you can do. All it does is it tells you, it computes the DC operating point, treating capacitances as open circuits and inductances as short circuits, because at DC, that's exactly what those components are going to do. So in this case, we've got no nonlinear active components like op amps or anything. All we got is some resistors on here. So our DC operating point simulation will work just fine. So if we press OK there, you'll notice that it's got the syntax down here, and that is the syntax for what's called the Spice Directive. And then it lets you put that on the circuit, and there it is down there. You can put it anywhere on the circuit you like, but it's got to be on there. And this is just the way LTSPICE happens to work in your more traditional command line approach. Then you'd be, typing in these commands, .op, which means operating point analysis. But because we've got that on our circuit now, that now tells LTSPICE, when we go up here to run the simulation, here it is, simulate run, it knows that it reads those SPICE directives and it knows exactly what to do. Now in the case of the DC operating point here, this will not show any waveforms at all, because there's nothing to graph, there's nothing to plot, there's no frequency responses, there's nothing. All it'll do is give us a text box of the various voltages and currents in this circuit. So let's actually run it. Here we go. We're going to run our first DC operating point simulation. Run, bang, and there it is. All it gave us is this list. But this list is actually very handy and very powerful for lots of different circuits, not just simple little resistor puzzle things like this. And here it is. It gives us the voltage at each of the nodes. So we have to know about nodes and each of the resistors and the current through each of the resistors down there from R1 through to R9 there. And you'll notice that some of them are negative. You'll notice that, say, R9, for example, is negative. Why is that the case? It's not necessarily because the current's running in the opposite direction. It actually depends on... Where's R9 here? Here it is. It depends on which way around you've put the resistor. And here's one of the first traps. Now, it doesn't actually tell you there's no indicator on there of which way the current's actually going to flow in this thing here. So what we're going to do is we're just going to move this resistor and we'll rotate that around. And if we run that again, you'll notice R9, bingo, is now positive. And once again, for R7 there and R3, so R7 and R3, we can rotate them as well, R7 and R3. But once again, you can muck around with this and get those values, or you can just leave it as it is. But just understand that the component, like a resistor, has a particular direction. It's not just, it's not just a random pin allocation. It treats the current flowing through in a certain direction like that. So we can run that and we should now get all positive currents there flowing through our resistors. Too easy. Bingo, we've done our first simulation that's DC operating point analysis. But the interesting thing is, once we've run that simulation, all that data is in memory in LTSPICE, and if we move our cursor over the individual components like this, look, if we move it over R1, you'll notice down in the bottom here, sorry I can't move my cursor towards it, but down in the bottom left corner, you'll notice that it shows you the DC operating point there is 1 milliamp, and it shows you the power dissipation in that resistor as well. And then likewise, say for R3 up here, there it is, 333 microamps flowing through that resistor with 111 microwatts power dissipation. And this one down here, you'll notice there's no current at all flowing through R5 and R6 here. And the next thing we can do is, once again, it's got all that data in that simulation data in there. It's ran the simulation, it's finished, has all that DC operating point data. We can just click on individual nodes here. Watch this. And we can get a value. Look at that, 1 volts. Look at that, 666 millivolts on that particular node there. And this one up here, 666, and so forth, and whoa, so on. Oops, we accidentally moved it off there. Don't move it off. And now that we have our voltages on there, what we can do is we can actually go in and change some values. Let's say we want to tweak that value there. Let's say it's 500 ohms now. And then we just run our simulation again. And bingo, look at that. Our values have changed. Now, the next thing you might want to do on a complex circuit that you're probing and things like that, you might want to label your net. So you can just right click on a net there and you can just label that net. You know, you might call it, I don't know, net 5 or something like that. But that just allows you to put meaningful labels that will then show up on your plots and stuff like that when you probe things. Or in this case, if we go in and run our simulation, bingo, it'll show net 5. There it is. It's automatically added in there. It's just more sensible when you've got a large circuit. So you know, like node 4 doesn't mean anything, right? Node 3, because they're not actually shown on the circuit. So it's good to go in there and actually label them so you know exactly what value is associated with what node. But of course, because this is a nice GUI interface, it allows you to put things like those voltages right on those nodes there. So you can sort of see it's a bit more interactive within the circuit. Now, of course, these voltage sources over here, you can actually enter all sorts of parametric information in them. In this case, in terms of a simple DC voltage source, there's the series resistance value down in here, which is a basic one. But let's say that battery, we were using, you know, a CR2032 coin cell battery or something, you know, and it's got a typical 10 ohm, you know, it might have a 10 ohms series resistance in the cell. So we can put that in and it's displayed that R series equals 10. And we can run that again and you'll notice that things are a little bit different because it's now taking into account the internal series resistance in that voltage source. So this is where you can start doing some real practical circuit implementations. And then inside the resistor, you can specify the tolerance in there, the power rating, and in future videos we'll get onto where those things will actually come into play in terms of various types of advanced analysis and temperature sweeping and all sorts of stuff like that. Now we can actually put more advanced information on this circuit. Let's say we wanted to get the current going through R7 here. Well, we click on this node again and we can put the information by default. It's just popped up there with that same node voltage we had before, but now we can actually right click on that and here's an expression editor which allows us to pretty much display anything we like. And in this case, we can change it, R7 there, we want the current through IR7, like that. Bingo! We've just now displayed the current through that resistor there. And let's say we wanted to display something simple like the voltage across R7 here. Well, that's not as easy as some other circuit simulation programs. Some of those other simpler ones for beginners might have like a multimeter tool and you drag in the multimeter. It has a little, it looks like a multimeter, has a little multimeter display, little probes, and then you hook it up across R7 and you can actually measure the value across that. But LTSPICE isn't catering to that sort of real ultra beginner market. It's more of just your, you know, professional, traditional SPICE circuit simulation. Well, the way you do it is I've labeled this net up here net 5 and this net down here net 4. So the voltage across R7, in this case, if you wanted positive up here and negative down here, it'd be net 5 minus net 4. So once again, we can just left click or click on that node there and it's given us a voltage by default. We go into the expression editor and you'll notice that it's only given us voltage and current for various voltage for all the nodes and the current through all the resistors, and that will depend on the circuit you have. That's the available data that it has. So that's the only data you have to work from. But we want net 5, we want our expression, whoop, I was doing too many clicks, we want net 5 minus net 4, like that. It's a very simple expression, and bingo, that is now the voltage across that resistor. Beautiful. And you can see that, it's taken us some time to just prepare our circuit and get nodes, net names and nodes and information and stuff like that. But once you've done that and you set it all up, then you can go in and play with all your values and then rerun the simulator. If we change this value down here to 850 ohms or something like that, then that's going to change all our values again. And bingo, there we go, they've all changed. So don't get frustrated with these tools that they don't give you absolute immediate results. You've got to work at it a bit and you've got to set them up to present the information. And we're only using the most basic DC operating point analysis here. We haven't even got into the probing and the graphs and all that sort of stuff set up yet. This is very, very simple, but yeah, as you can see, not as user-friendly as some other Spice engines out there for beginners, but it's not that hard to learn at all. And once you know how to use it, you can get it to present the information that you want. And even for more complex circuits like this audio transistor-based audio amplifier that comes with LTSPICE, comes with lots of example circuits, by the way, already set up, ready to run. They've already got the various Spice simulation directives down here to do, some Fourier stuff and, transfer function, all sorts of things like that. But one thing it doesn't have is a DC operating point. So let's go up there and we'll edit our simulation command, DC operating point, and we can just use our operating point command. And we can place that there. It doesn't have to be there. It can be anywhere on our circuit. And then we can just run that. And that will provide, once again, all those DC operating points for all of our transistor amplifier there. And once again, we can do the same thing and we can go in there and we can put the various voltages on those various nodes in there. So that's our DC operating point stuff. Very handy. And when you get to more complex circuits like this that have more than just your passive components, they've got transistors and op amps and things like that, then you need to pick the particular type of component that you want. Now, there can be generic ones, but in this case, you can pick various transistors. And LTSPICE, for example, comes with a whole bunch of basic transistors. It may not have the exact one you have, and we'll do a separate video on how to add external Spice models, but you'll see that it has all the Spice model information all pre-programmed into files which you can get access to, but they're basically just hidden away in there with all the detailed Spice information and all this gobbledygook, which probably means very little to you. And some of these Spice models can get very advanced because they're, as I said right at the start, designed for semiconductor modeling, silicon level modeling, so you can get into the whole physics and the manufacturing processes. And these Spice engines let you go into as deep a model as you require for your particular type of component. But it does come with a good selection of basic or a usable selection of basic transistors, for example. And then if you go into op amps, if we go up here, these will all be separate tutorials, of course, but we can go over here and then op amps, and of course LTSPICE only comes with all the LT ones. It doesn't have, you won't find an LM741 in there, for example, but it does have generic ones like just a Jelly Bean op amp like that. And that becomes a very important part of any Spice model, whether you're using just the generic one like this, which is basically an ideal model op amp. It doesn't have all the, the real-world information programmed into them as these other ones do. There's the specific LT. That's a 2.7 gigahertz low-noise rail-to-rail differential amplifier driver. Ooh, that looks pretty good, actually. I like the look of that one, but that'll have... and then you can open the macro model's test fixture, and, oh, man, it's just, you can test the individual parts. And, woo, these circuit simulation Spice things, they've got so much depth to them. I could probably do 100 videos and I'm still not going to cover everything. There's always something new to learn when you're playing around with circuit simulators like this, trust me. So that was a basic look at the simplest Spice simulation analysis you can do, DC operating point analysis. And so many tutorials out there just completely skip that first basic step. They go straight into transient analysis, which allows you to, because it has the eye candy, it allows you to probe waveforms and see your like oscilloscope-like waveforms around your circuit. But really, that is a more advanced analysis feature than your basic DC operating point stuff. So this is very important to know, and as a first step to your SPICE analysis. Yes, it's not very sexy, but it's vital to know. So I hope you found that useful, and there will be follow-up videos with all sorts of different types of analysis options. Catch you next time.